Within the category of functions, we have lots of different kinds of functions that we can work with, one of which is continuous functions. And continuous functions are functions that that exist for every x value. Meaning that there is a value, there is a part of the graph, no matter how far side to side we have gone. Okay, so that means that we are going to have no gaps, holes, or breaks. The graph is going to exist without any disruption to it. And our key for testing it is that it can be drawn without lifting your pencil. So that's like our pencil test. You can draw this function out without ever having to lift up your pencil. Okay? You're continuously drawing. Our equation is just going to look something like f of x equals, okay? And then some sort of equation, okay? There are no parameters. There are no limits to it. It's just an equation. It's just going to say f of x equals. Continuous functions are our most basic and might be what you're most familiar with. Now, we're going to draw two different graphs, so you're going to need two different colors. If you don't have two different colors, now would be a good time to pause the video and grab two different colors. So the first graph that I'm going to draw is a continuous function that exists with sort of some unique properties. So my purple graph, remember my domain talks about how far side to side I go. So my domain is going to start with negative infinity, and it's going to go till positive infinity. Now you'll notice that I use open parentheses, okay? These parentheses mean that I approach but never hit. Because I can approach infinity, but I can never actually hit infinity. So I'm going to use those parentheses. Okay. Now, the next thing we're going to have is the range. Okay. And the range is going to go from, well, what's the lowest that my graph is at? The lowest that my graph is at is going down towards forever, forever, forever. So I'm going to have negative infinity, and I follow it up, and the highest it goes is going all the way up to positive infinity. So my range is going to be negative infinity to positive infinity. This is what we call interval notation, where we don't have any less than or equal to signs. So we just say what is the section that our domain and range is including. Now that is one type of continuous graph. Just one type. Let's see if this is going to let me do what I want it to do. Here we go. Uh-oh. Thanks for your patience. So that was one kind of continuous graph, was what we had in purple. The next kind we're going to draw in a different color, and that's going to look something like this. It's going to go on forever in both directions, but it's going to have a height that it never goes past. So here we have some hills, and you'll see the arrows both post down. And the highest point that I ever get to is where y equals 0. That's that point there. And so there's a top to my, or a maximum to my range. My domain is going to be Well, let's see how far to the left do we go. This arrow is going down and over, so that means that the furthest to the left I go is negative infinity. And the furthest to the right I go is positive infinity. Okay, because we're doing that same thing. My domain is always going to be negative infinity to positive infinity for a continuous function. Okay, in order to be a continuous function, it will always be, let me get a marker here. Oops, let's make that a little clearer. It will always be negative infinity to positive infinity. What changes can be the range. So my range, we're going to start with how low does my graph go, and it goes at negative infinity. That's great. Same as normal. But this has a maximum or a top part or the highest part that it can go, and that is at 0. My graph is never going to go higher than 0, so that's what I put as my maximum or the end of my range. And it looks like my graph does hit that point, so I'm going to use a closed bracket. A closed bracket, opposed to that curved open parenthesis, means the graph hits that point. So that is domain and range of a continuous function, where the range might have a minimum or a maximum, but the domain will always be negative infinity to positive infinity.